Slide 1. Today, we thoroughly analyze TSMC's COUPE, technology and structural shift in the supply chain, the revolution from copper to light, triggered by silicon photonics. The evolution of AI and high performance. Computing is presenting the semiconductor industry with two massive walls, the I/O wall and the power wall. No matter how fast computation becomes, it is meaningless if data transfer cannot keep up and power consumption explodes. TSMC's answer to this challenge is COUPE. This is not just a new technology. It is an irreversible paradigm shift that physically replaces the nervous system of data centers, from copper wires to light. Behind this revolution, which companies will emerge as the new winners? I will unravel this with dense original analysis, including the trends of niche-top companies like Himax Technologies and Foci, which investors often overlook. Slide 2. Why light now? The limit of copper. First, let's review the physical background of why light is necessary now. In current data centers, electrical signals are used for communication between servers. But as communication speeds increase, electrical signals degrade rapidly with distance. To correct this, correction circuits such as retimers and DSPs are required. But these consume enormous amounts of power. In fact, more than 30% of the entire system's power is wasted on communication rather than computation. The only technology that can save this energy crisis is silicon photonics. By converting electricity to light for transmission loss is dramatically reduced, and bandwidth can be improved by leaps and bounds. Slide 3. Innovation of COUPE 3D stacking and hybrid bonding. COUPE, developed by TSMC, stands for Compact Universal Photonic Engine. Its greatest feature lies in the use of the company's 3D stacking technology, SOICX. In COUPE, the EIC electronic integrated circuit and PIC photonic integrated circuit are stacked using bumpless hybrid bonding, which directly bonds copper to copper without using bump solder. This eliminates resistance and parasitic capacitance in the electrical path to the extreme, realizing overwhelming energy efficiency compared to conventional connection methods. The EIC adopts a 65-nanometer process, ensuring high voltage tolerance while optimizing cost efficiency. Slide 4. Strength of solid structure, integration of micro-lens. The biggest challenge in silicon photonics is coupling loss when passing light between the optical fiber and the chip. COUPE tackles this problem with a solid structure and micro-lens. By embedding ultra-fine micro-lenses on the chip surface, coupling loss is suppressed to an extremely low value of 0.3 decibels. Furthermore, this structure is mechanically robust and free from external contamination risks. The tolerance for alignment with optical fibers has also been relaxed to plus or minus 10 microns, which dramatically improves yields during mass production. The awesomeness of TSMC lies in sublimating laboratory-level technology into mass-producible industrial products. Slide 5. Performance indicators, dramatic impedance reduction. With the introduction of COUPE, system performance improves significantly. Of note is power-saving performance. Hybrid bonding drastically lowers the connection impedance between dies. This realizes a power consumption reduction of more than 40% for the entire system, compared to conventional optical modules. Also, latency is shortened to 110th to 120th due to the shorter electrical signal path. By cutting the waste of physical connections to the extreme, they are securing the efficiency to withstand next-generation high-speed communication. Slide 6. Roadmap from module to CPO. TSMC plans to introduce this technology to the market in 3 stages. Phase 1 is from 2025 to 2026. First, COUPE will be mounted as an engine inside existing optical transceiver modules. The first adopter is predicted to be AMD. Phase 2 is from 2026 to 2028. This is the main event. As CPO co-packaged optics, adoption in NVIDIA's next-generation GPU Rubin generation, or the generation after that, is viewed as a strong possibility. And in Phase 3, the function will be integrated into the interposer itself, completing the ultimate optical I/O. Slide 7. Supply chain. Winner 1. Himax Technologies. This is the most important part for investors. Who will profit from this revolution? The first winner is Taiwan's Himax Technologies. In the micro-lens array, which is key to COUPE, Himax has established the position of TSMC's exclusive supplier. Their wafer-level optics WLO technology is the one and only technology to create ultra-fine lenses in the semiconductor process. Analysts predict that Himax's revenue could double by 2028 due to the expanded adoption of COUPE. They are truly the hidden giant in the COUPE ecosystem. Slide 8. Supply chain winner 2 of Foci and Relficon. The second winner is also from Taiwan, Foci. They supply the Fiber Array Unit FAU that connects optical fibers and chips. Foki's strength lies in a patented technology called Photon. Conventional fiber units were weak against heat and could not withstand reflow, soldering, a semiconductor manufacturing process. However, Photon solved this thermal problem, enabling manufacturing on standard automated assembly lines. This is the decisive reason why it was adopted by TSMC, building an exclusive position in phases 1 and 2. Slide 9, Ecosystem Restructuring Foundry Hegemony. This technological shift fundamentally overturns the industry's power balance. The optical communication market has been crowded with many module manufacturers, but in the CPO era, the foundry TSMC will hold all the leadership. In design tools, EDA, Synopsys, and Ansys are deeply collaborating with TSMC to establish an environment for simultaneous analysis of electricity, light, and heat. OSATs responsible for back-end processes, such as ASE and Amkor, are also rushing to adapt to this new ecosystem. The source of value is shifting completely from module assembly to foundry-led integrated packaging. Slide 10, Conclusion. By the light enablers. In conclusion, TSMC's COUPE is a game-changer that turns silicon photonics from a dream technology to the standard for AI infrastructure. From 2026 onwards, the physical layer of data centers will irreversibly shift from copper to light. To ride this wave, simply looking at semiconductor manufacturers is insufficient. Focus on the enablers who resolve the technical bottlenecks. Himax for microlenses, Foki for heat-resistant fiber connections, and TSMC, which integrates these and reigns as the kingmaker of the AI era. Investing in the era of light begins with securing these certain winners.